Awesome. Right. Okay. So it's 1 minute after past. So we'll get started. Hi, everybody, and welcome to our February 2022 meetup. The Open Source Satellite Programme runs regular meetups on a diverse range of topics related to space-based and space-enabled systems, from the deeply technical through to matters related to the wider space ecosystem. And that's where today's session fits in. We're going to be looking at the space ecosystem and considering the diversity of opportunities that exist for developing a space-related career. The Open Source Satellite Programme, sorry, Catherine, next slide, please. Thank you.
Right, just getting myself organised.
So the Open Source Satellite Programme was established by KISP, and our vision for the Open Source Satellite Programme is to make space more accessible and to promote the responsible and sustainable utilisation of space. Through our own personal experiences in designing, building and operating spacecraft and the full system architecture, we've seen at first hand the utility of small satellites, the ideas that they've stimulated and the value that they have provided to many sectors and industries. And we can see the future potential of small satellites to influence and make a positive impact to everyone's lives. The Open Source Satellite Programme is being developed for the open source community by the open source community, and there are lots of different ways to get actively involved and to follow what we're doing, and we'll provide you with this information at the end of today's session. So let's take a look at the format for today. Next slide, please, Catherine.
Sorry, forgetting it's me.
Thank you. So we're going to spend the majority of today's session describing the space ecosystem, describing the career opportunities that exist in the industry, and we'll also take a look at some of the different routes to a career in space. And then we'll share some insights into the career journeys of some of the KISP team. And ideally, we'll hear from some of today's audience too on how you've got to where you are today, or perhaps what your aspirations are. And I really do hope we'll have time to open it up to the floor. So without further delay, let's get started. I'm delighted to introduce Dr. Catherine Graham, today's presenter. And Catherine's joined the KISP and OSAT teams after over 2 decades of success in small satellites and high altitude vehicles. And Catherine was also the presenter for our January meetup on Space for Good. And the recording of that session is available for playback on the Open Source Satellite YouTube channel. So Catherine, welcome, and over to you.
Thank you, Anita. It's my pleasure to be doing my second presentation for this forum. So, and hopefully we'll have a good one. So who am I? Catherine Graham. I've recently joined KISP as a system engineer. I'm not going to talk any more about my career because I've got a slide later showing my career route and how I've got to this point. So I shall leave that for later. So we'll just get stuck right in. So today's theme is careers in space. So why space for a career? Oh, no, sorry. There you go. Why space for a career? Well, it's exciting and inspiring, first off. I remember as a kid looking through encyclopedias and being fascinated by space. I remember in particular a diagram of the evolution of stars that had me, I had my attention for many hours and looking at pictures of space nebulae and stuff, etc., etc. And I found the whole topic of space exciting and inspiring. And I was very lucky to have been able to pursue a career in space and to actually follow it into my whole career. So it's exciting, inspiring. It's a thriving industry, and it's a huge industry with a lot of growth. I'm going to particularly concentrate on the UK, but around the world, this is a growing industry. Countries that have never even considered having a space industry are now getting involved and beginning to set up space industries and launch satellites, and so get into the space business. So it's a truly global industry that is thriving and growing across the board. It's got cutting edge science and technology, so to driving things forward. So it's exciting work that you can be doing. And space skills are in high demand. There is a current shortage in the UK of people with space domain experience. In addition to that, if you do work in the space industry, they're highly transferable skills. So you can go and use them in other industries, either before or afterwards, both in technical and soft skills as well. And if you want to work in a highly collaborative working environment and part of a team to produce something exciting and thrilling that has value for many people aside, you can't beat the space industry for giving you that kind of work, basically. It's a booming space industry in the UK. This is just a map of just a small fraction actually of the companies involved in space around the country. And it's not all just in one location, spread throughout the UK. And there's some regions that are sort of forming little hubs of space communities. Certainly in the Hampshire, Surrey area where we're based, there are several space companies located. London has another area. The Harwell Space Cluster, I've only put a fraction of the space organisations that are ranging from ESA, because ESA have a branch at Harwell, the Catapult, some of the big companies like Lockheed and Deimos, but a lot of small space startups are also located in Harwell, in Oxfordshire. And Scotland has a thriving space community as well. And again, not all the space companies that we've got there, are listed in that little diagram. And there's other space companies scattered throughout the rest of the UK, so don't feel that they're only in those hubs. So it's a huge industry, and it's one of the fastest growing sectors in the UK economy, supporting over 117,000 people. And so with the right motivation and skills, you can join in and get involved into the space industry. So what types of careers can you do in space industry? Well, I'm just going to do a few overviews of space itself. What do we use space for? So we use it for science, communications and internet, disaster monitoring, agriculture, Internet of Things and data collection, environmental monitoring and enforcement, remote sensing, satellite navigation, and many, many more applications. So the space industry scope is huge. So there's the upstream element, which is the part where we design and build the spacecraft, but that's just a small element of the whole space industry. So there's all the elements, the ground segment, the commissioning and the operations part, university and teaching, the launch segment. There's also a big region in human space and astrobiology areas as well. And then the downstream, which are the users of space. And so there's a whole range of different applications and organization types and types of work that are involved in the downstream applications from space. So it's not just limited to actually designing and building a spacecraft if you want to be involved in the space industry. It's a much wider ecosystem. So concentrating on the upstream, so there's a whole life cycle that we go through, which requires different skills and talents as you go through. So it's from the early stage concept development, thinking, coming up with ideas, or being presented with ideas and thinking about how you might meet and design something for that concept. And then once you get through whittling down all the different ideas and you decide on a route, there's the design phase, which requires a wide range of engineering talents and skills to actually pull those designs together and come up with a design to then go and build. Then you go and build it and then test it and get it ready for launch and do the launch and then commission and operate. And all this, so that's the life cycle you go through in developing a mission. So that you need a wide range of skills to perform all those different functions. Also within a spacecraft, there are lots of different elements within that spacecraft to consider in terms of what kind of skills are needed to be able to develop those craft. We've got payloads, which can be optical or RF or GNSS type payloads. You've got the power generation and storage, the structural elements, the onboard data handling, communications, attitude determination and control, your propulsion subsystem, and then all the environment work that also goes in to make sure that that spacecraft will operate in space. And all those different elements that go in to make a spacecraft require a range of different skills in order to pull all that together. So the next slide, which will take a little while to go through, is some of the space jobs stemming from that, which you can do, which come from that. So for designing your payloads, optical design and optical build, RF engineers, all those skills to develop the different types of payloads, the GNSS payloads in terms of understanding the RF signals and the signal processing and the software. So there's a whole range of different skills that are needed to pull a payload together. Engineers, we use solar panels and batteries, power conditioning, and these all need engineers that understand how these processes work and to design it and build it, and then also the build element. So we need mechanical engineers to build the structures together, the different elements to pull things together, and it needs MCAD designers that can draw the diagrams and in the packages so you can go out to build. You need to be able to do the finite element analysis, the structural analysis. There's a whole range of different skills on the mechanical front, and a whole range of practical skills of also not just designing it, but also thinking about how the craft will be built in practical terms, allowing space for things like harnessing and allowing gaps for outgassing, etc. So there's a whole range of different skills needed in that area. Electrical and electronic skills. Spacecraft are made with obviously electrical components that are specifically designed for the function. And so there is a whole range of job opportunities and skills needed in order to design boards, onboard computers, memory processing, whole range of areas, and then design it, build it, so ECAD, right through, and then obviously right through to the actual making of those components as well. So RF engineering, like I said, there's communication payloads which need RF engineering, but also the TT and C systems on the spacecraft require RF engineers. AOCS engineers, so attitude and orbit control. So those are very different skills. There's a lot of control theory that goes on for our attitude control systems. So it requires some mathematical skills in terms of doing the control algorithms. But in itself, an AOCS system is a system in itself, and so requires an element of system engineering and pulling all the different sensor inputs together and putting control algorithm and then feeding that through to the control systems of it. So a highly complicated subsystem just on its own, which needs a range of skills in order to do it. Propulsion engineers, so designing propulsion systems, making pipe work, making tanks to put fuel in. So there's a whole massive range of work that just needs to go in to produce a propulsion system. So we've also got thermal and radiation engineers to pull together the environment. So it's thermal analysis, understanding how the spacecraft behaves in the widely varying thermal environment that the spacecraft operates in, operating in sunshine up to 70 or 80 degrees, and then in eclipse going down to say -20. So that needs a fairly detailed thermal analysis to understand the different orbits, how that will affect the spacecraft, where's going to get hot, where's going to get cold. And then there's radiation analysis. The space environment is not pleasant, it's above the atmosphere. So we need to understand how radiation will affect the components. So there's overall radiation analysis in terms of what kind of dose the spacecraft will receive, but also more detailed sector analysis and where in particular you might need to put some shielding to protect it. So other areas, space assembly and test engineers. So once you've built all the components, you need to, all the different elements, you need to build it up together. And that's working in clean rooms, putting the parts together in a precise way, very clean way, and making sure that you don't damage the craft as you build it together, and doing all the testing to ensure as you build the spacecraft up, it will work and operate. Because once the craft is in orbit, we're not going to be able to go up and fix it. So it needs to work once it gets there. So it's a very rigorous and detailed testing campaign that we need to go through. As I said, we design all the components, etc. So you need some PCB and manufacturing capability to build those boards together, to put those boards ready for space. And again, you need to consider the fact it will be operating in space. So there's extra consideration and choice of parts and components in terms of making sure they are suitable for the space environment. Then you could argue, then it's the glue in many respects, the system engineers. These are the engineers that work with all the other disciplines, pulling it all together, making sure that as a whole, the whole system comes together and works. So I'm making sure if there's a change in one area that is understood, and make sure that any impacts across other areas are passed through. Handling the requirements, making sure that everyone knows what is needed to be done to make that mission work is happening and functioning, and responsible for the overall test program and making sure that at the end of the day that product meets what the requirements are for that mission. So, and at the early stage of a mission, when you design it, you need concept design engineers, those that can think slightly out of the box, can think about how you would actually go about meeting a mission requirement, and be able to handle quite a lot of different types of ways of pulling a mission together, handle woolly requirements in terms of a vague notion of what might be a good idea, and pull that together to something that you can then get to a point where you could think about going and building, going ahead and doing the detailed design from. So, and an area that I've not been involved in, but certainly in a lot of space industry areas, there's a human factor area where we have astronauts going into space, etc. There's a whole range of human factors that need to be considered, and a whole realm of science that goes on in looking after people that are going and traveling into space and making sure it's safe, from the biological side in terms of muscle degeneration and skeletal degeneration, so the psychological side of ensuring that people have got the right psychological makeup to travel into space, into that harsh environment with a restricted number of group of people, ensuring that all works together. And that will only grow in the future as we look to the future of having colonies on the moon and Mars. Then these areas are only going to grow and develop further. So that was an overview of some of the potential technical roles in space, and there's a huge number, and there'll be some that I will have missed, and you would be going, oh, but you haven't talked about this one. Software, I barely mentioned. Software is a huge component of putting a spacecraft together. It was on a bullet, it's hidden away. So software is a huge element and often overlooked, and shouldn't be overlooked because it's critical, because it pulls all those units together and makes sure that when the satellite is up there and operating, it does the job it's supposed to do, and handles all the safety procedures if something goes wrong on the spacecraft. It's the software that's going to catch it and hopefully turn units off and put safe modes in, etc. So software is a critical component of the whole thing, and there's a whole range of different software, from flight code to embedded code, whole range of opportunities to get involved in the space industry from a software perspective. And here I've only spoken about the satellite end and the going into space bit. There is a whole ground segment end which needs a range of technical skills. So from the ground stations and the operations and operators understanding how to operate spacecraft. There's the launch segment, from designing the rockets to running a launch site to getting the craft up into the launch before you even get onto the downstream elements. So there's a huge range of technical work opportunities. But it's not just technical, it's not just the STEM roles. There are a whole load of other functions that are needed to make the space business successful. So, and it's like any other industry, actually. You need your project managers, you need the finance people, the support staff, the IT resources, human resources, purchasing and procurement, facility management, contract management, marketing and publicity, development, business development, sales. There's a whole legal and legislative support that's quite unique in terms of, if you think about firing a rocket from a spaceport, you can't just go and do it. There's a whole load of legislative work that needs to be done and licenses that need to be got. Entrepreneurs, we've seen the growth of new space in the last 3 years, people having a bright idea and setting up companies and working and bringing those ideas to fruition. And we need entrepreneurs to come up with those ideas and get those groups of people together. And then insurance as well. There is a huge industry just around insurance for the space industry, because to launch a satellite, you need insurance in the first place, but also, there's a whole range of understanding the risk, etc. And those are just a few of the things that I could think of just in supporting a space business. So basically, in conclusion, in terms of the realms of jobs available in the space industry, it is huge, and it's not just all about engineering and science. There is a huge area around that in terms of support skills, etc. So I thought the space industry is big. There's lots of areas you can get into. So how do I launch my career into space? So this chart is slightly flippant, which I found on the internet. Which is the right space career for you? Talks about questions of, do you like flying? And so if you like flying, you're a good pilot, you might want to consider an astronaut. So it talks about what the idea it's trying to get across is we need a whole range of different skills in different areas in the space industry. And so depending on your skill set and your talents will hopefully drive you to the right area in space industry. So this flowchart describes some potential career routes. It does not cover all the potential career routes that there are. So it's just some potential routes. So if we take the standard traditional route into technical space at GCSE level or 16 in the UK, take STEM related subjects. So your science, your technology, engineering and maths subjects. And following on from post 16, doing A levels again in the STEM subjects, physics, maths, and some other science potentially, or another subject. And then going on and doing a degree in some engineering, physics or maths, or potentially computing discipline as a traditional route. And then you can either go straight into a graduate role in space, or go on and do a master's or PhD in some space or engineering related discipline. So it's quite common that if you do a general engineering type degree, you might go and then do a more specialist MSc in space and then go on and do a graduate role. So that's perceived sort of as a traditional route into space. But there are many other routes, and there are lots of other other ways through into space, and that's growing all the time. You could, instead of doing A levels, do a more vocational subjects approach, do a BTEC in engineering or science, which are their grades are assessed as equivalent to A levels, and then you could go on and do a degree in engineering or physics from there. If you do a BTEC in as more science and applied science, you might need to do a foundation year first, because often the engineering degrees require an A-level maths. So you might need to just look carefully in that department. But you can go from BTECs to degrees in engineering and then carry on the traditional route. Or you could do a BTEC and go and do an apprenticeship. There are level 6 apprenticeships around, and a level 6 apprenticeship is a degree level where you work, you're employed in a company and do an apprenticeship with a college. At the moment, there isn't a space level 6, but it's just in the process of being designed and hopefully will be released in the next year. So there is definitely coming in the very near future, a space technician, a space apprenticeship at level 6. And then you can go on and join you will come out with a degree equivalent apprenticeship and go and get a grad role. Or these apprenticeship roles can be located with a space company, and once you're in your space company, you've got your space job, and you can follow your career route in your space job. What is around now, and you can go out now, is a level 4 space apprenticeship. So you can go straight from your GCSEs, straight from school at 16, and go and get an apprenticeship with a space company doing space activities. And that's at a technician level, and then follow a career route through once you get into the company. It doesn't need to be space, it could be another engineering discipline, and that's another potential route into a company. So that's sort of some potential technical routes in. But if you might not be technically minded, so you might do some non-STEM subjects, and you can then follow a non-technical career route in space, go and do some different degrees, do the disciplines that are relevant to the area of the space business you want to get into: project management, finance, business, all those areas, and you can move into a non-technical role in a space company. But if you decided actually, even if you've studied non-STEM subjects after 16 and you think, oh no, I really wanted to get into a technical role, there are still routes in. You can go and do foundation year engineering and science courses for a year, and then go and do an engineering degree through many universities or the Open University. So there is no dead end in terms of just because you've gone a particular career route, it means that you can't find a way into doing what you want to do. So basically, if you're passionate about space, there are many roles and routes into the space industry. Just need to work hard, get involved in space activities, do some work experience, get involved in club societies, and find a way in. So there's lots of routes. So talking about routes into space career, I suppose I should tell you mine. So this is mine in pictures. Oh, I've got a moving picture. Didn't know I had a moving picture. I did O-levels. I'm that old. I did O-levels. So I did some O-levels, physics, chemistry, maths, and then went on and I did the traditional career route. And then I did A-level physics, chemistry, and maths. I was quite intrigued to find a picture of my old physics textbook that I remember having at school. And then I went off to Birmingham University to study physics with astrophysics. I spent 3 fantastic years studying physics and astrophysics. And yeah, that picture there of the Pleiades cluster, that featured in my second year dissertation, which I really enjoyed doing. And then I was really fortunate and lucky to go to Leicester University to do a PhD in X-ray astronomy. So that's a picture of the ROSAT satellite, which is now deorbited, which was the satellite I used mainly for my PhD, looking at magnetic observations of magnetic cataclysmic variables. That's a bit of a mouthful. I also was extremely lucky to go to the Mauna Kea, an observatory on Mauna Kea, the United Kingdom Infrared Telescope, for a few nights to get some data there. So that was a great start. Then I got a job at what was then DRA, that then very quickly became DERA and then became Kinetic, in the space department there. I spent 10 years working there, mainly on mission concepts and space-based surveillance applications. Finally completing my term there, working on a mission called TopSat, which was an imaging mission for the Ministry of Defence. And following on from there, I was lucky to get a role at Surrey Satellite Technology. I spent 13 years there, initially working in mission concepts, and then and studies, and then moving into system engineering, running the system engineering team for many years, and growing my team. So I was running system engineering, AOCS, and thermal by the time I left there. Really great working on a fantastic range of projects and working with a fantastic team of people. So just over a year ago, I decided to move on and try something new. It's always good to shake things up a little bit in a career. And I moved out of the space business, but not too far, just a few kilometres down. And I moved to a company called Prismatic that worked on high altitude UAVs to become and I took a more leadership role doing the chief operating officer there, which taught me a whole different business area and a whole new range of skills and types of work. And I had a great year there, but I concluded at the end of towards the end of that year that although it was fantastic, it was really interesting, there was no getting away from the fact I love space. So I'm now back in the space industry doing some really exciting technical work, which I'm loving, getting my hands on, getting my hands back into it, getting back into doing real engineering and working here at KISP. I'm thoroughly enjoying it. So it's a fairly traditional route, but it also shows that you can go out and try something different for a while. If it doesn't work, that doesn't matter. Just, or well, not doesn't work, but if you feel it's not quite for you, just go. You can change the route and get back on track, as it were. So I'm now going to move on to one of our other members of KISP who's going to talk about his journey into space, which is very different to mine. So if you're ready, Jamie.
Hi everyone, I'm James, or Jamie. I'm a trainee software engineer at KISSpace. My journey's been vastly different to most. I didn't get on very well at school. I've got Asperger's, and I didn't receive kind of the support that I needed at the time. This was about 10 years ago when I was of school age. I don't have any qualifications beyond AS levels, which is the first year of A levels. But when I was at A levels, I was quite into computer science, which is one of the subjects I did. I didn't do very well, but I ended up dropping out. And then I got involved with another one of the KISP team, Paul Madel, who will be on the call a bit later. He's a senior software engineer, and he ran a code club in the local village that we lived in. And I got a bit involved with that. We were working on making a Pong game on a little microcontroller. I quite enjoyed that, but inevitably gave that up as well. Many years later of just being in dead-end jobs, I end up ringing him again, and I'm like, hey Paul, do you still run that code club? So got back involved with him about two or 3 years ago, and we wrote a little app for a smartwatch for a young fella who had seizures. I think it was to detect something so that he would, oh no, he'd had a stroke. So it was to remind him to do exercises on the side of his body that needed strengthening. So we plodded along for a bit. I was working at a pub at the time, and then all of a sudden, Paul gets a phone call from me. Hi, it's Jamie. I need a job. I'm going to be a dad. So after a while of putting CV together and trying to find some software jobs at different places, I get an interview with him at the University of Surrey. So we end up taking a drive down to Guildford, Farnborough, and I'm sat in a room full of professors. This kid who comes from quite a low income area in the Midlands, sweating his pants off, trying to talk about himself, feeling completely fish out of water. But after that interview, I was taken around SSTL and went for a bit of a tour around there. And I got to see the clean room. I got to see all bits and bobs in there, which completely blew my mind. And I was like, wow, space. Well, this is something I can do. Definitely. Like, that's so cool. So fast forward a little bit, and I get accepted to do this project with the University of Surrey. I'm writing testbed code to test microcontrollers in the space environment. So that's putting them in a radiation chamber that they had at the University of Surrey and dosing them with radiation and seeing how they hold up. So that project went successfully, and we went on and did a follow-on project. And then and then KISP decided to then take me on full-time after then. So I've been working for KISP now since March last year, and now I'm writing flight code. So it goes to show that no matter where you come from, no matter your ability or disability, there's a place for you in space.
Absolutely. Absolutely. It's a pleasure to have you on board. Brilliant. Okay. Who's next? So Sophie, you able to go next?
Yeah, sure. So I'm Sophie. So I joined KISP just over 2 years ago now as a graduate engineer. So my route into space was a bit more conventional. So I did a master's in engineering for aerospace engineering at Bristol. So that was an integrated course. That was a 4-year course. So I did a lot of the engineering for more focusing more on aircraft rather than space. But I tried to take space related modules where I could, and get involved with some of the space clubs at University of Bristol. So I found I was much more interested in space, but after taking part in those activities, and then after finishing my course, I also did alongside my course, I did a activity week with the European Space Agency. So it was a concurrent engineering program, which was really cool opportunity to get involved with lots of different people from all over Europe in a big project. So it was about 30, 40 people working in different subsystems like the ones Catherine mentioned earlier. So all those different AOCS engineers and systems engineers, and looking at all those different subsystems and coming up with a concept just all in the space of 1 week. So that was a really cool program that really made me interested in getting involved in more space programs. So after my course, I was applying to space graduate engineer roles. So I was luckily accepted at KISP, and I started work on space situational awareness work. So that's looking at the near Earth orbit and looking at what's up there, what can affect the spacecraft that we have up there. How do we keep an eye on our local space environment to keep it healthy, and how do we monitor what else is up there? So it's looking at projects like that when I first started, and then moving more towards some mission concept work, as well as developing some programs for modeling some of those missions. So looking at orbit control software and mission planning software. So looking at how to develop that and how we can model some of those missions that we're interested in. And then from there, I've just been working on some systems work and some CAD modeling work and electronics modeling work. So wherever I've been useful, wherever I can be useful, I've tried to be useful, I guess. Yeah, so that's probably more of a more conventional route, but I've tried to get into space where I could.
Okay, thank you, Sophie. Vicky?
Yeah, lovely. So I was reasonably good at school with that, and I went on and did science-based A-levels, though I was told at the time they were boys subjects I was picking, which was a nice, nice starting point to kick that part of my my life off. And when I was at school, I enjoyed maths and science and computing, but I didn't really know what I wanted to do. I mean, I'd always wanted to be an astronaut, which I think is like kind of that route for a lot of people who like space, but not being in America, I kind of figured that was something that was never going to happen, and space was cool, but it wasn't something I was going to, be able to get involved in. Lucky I had quite an enthusiastic physics teacher at college, and he put me on to going to Bristol University for a week to kind of try out different bits of engineering. And while I was there, I found I quite liked electronics. I liked that kind of hands-on aspect. I like seeing lights come on and off and seeing things work. And so I thought, oh, this is maybe the thing for me. So to put off having to get a job, I went to university and did electronics, and I did it with space science and technology. So And that was because it was interesting. Space was interesting to me, but I didn't feel confident because I'm actually very, very practically minded. I thought I'd better get a degree where I could get a job. I could hear my parents' voice in my ear, because otherwise I would have done like kind of an Indiana Jones style kind of what do you call it, archaeology or something of that nature. But I was like, I'm going to do a job that has get a job at the end, degree, get a job at the end, and go forward with. So I went and did electronics, space science, and technology. Finished my degree, and I went and got a job in the defense industry, and I did that for a number of years, doing kind of electronics design. And I saw a job come up at Surrey Satellites for doing electronics, and I thought, and to me it really was, it felt like quite a wild card option to have a go and apply and see if I could go and do something in the space industry. Anyways, I got accepted, and I spent a number of happy years there, and it's really nice to know that I've got some kit in space that's takes some nice pictures, and and people are getting kind of the benefit out of those. As everyone probably appreciates, life moves on a bit. Unfortunately, Surrey was no longer a place for me in terms of like location and the like, and so I went back into the defence industry, which was fine, but it never quite floated my boat in the same way. So I actually transitioned. So when I changed roles from Surrey to back in the defence industry, one of the things that would niggle at me, so I was an electronics engineer and I did a lot of digital design, and that's a lot of ones and zeros and real kind of detail work, and which I enjoyed. But what would annoy me is lots of things would fall down the gaps because people didn't have that big picture view of how all these ones and zeros have to go together to make something work. And I found over time, I was like, oh, actually, this is something that I'm interested in and I would like to get more involved in. So I actually moved across from electronics engineer to become a systems engineer. So like a lot of big picture stuff, kind of look at how things go together and how you plug all the widgets, to make something cool happen. And I was very fortunate while I was at my company where I took this role on, is they gave me the opportunity to do an apprenticeship. So it was a level 7 apprenticeship. So it's a postgraduate qualification. And I spent some very frantic years trying to do a part-time degree around my full-time job, which is great fun. But I got a postgraduate diploma qualification in systems engineering. And shortly after I got that, the opportunity came up to come along to KISP. So I'm really pleased to say that I've been able to take kind of my experience and kind of my, I guess some of my more formalized system stuff and actually come here and work here at KISP as a senior system engineer. And I think it's fair to say, and I think the others on the team who work with me, no 2 days here are the same. And we definitely get involved with a whole branch of stuff. And I'm looking forward to having some more stuff in orbit, hopefully very soon. So that's me.
Excellent. Now I'm going to open this up. Thank you, Vicky. It was brilliant. I'm going to open this up. Is there anyone else on the call that wants to talk about their route into space?
I mean, I can discuss perhaps my progress so far.
Yeah, that'd be fab.
If that's okay.
Yeah, that would be great.
So I've always wanted to go into space.
Sonny, do you think you could introduce yourself for us?
Oh, sorry.
Yes.
Yeah, so I've put Sonny up on here, but I'm Sunil Dillon. That's my full name. Originally from Wales area, so I may be able to pick up the Welsh accent. Yeah, so I've always been very much interested in space. I'm not going to lie, I've always wanted to be an astronaut and still do. I'm just putting that out there.
Join the club.
Yeah, and well, I've got my successfully got my undergrad in mechanical engineering. Always been interested in Mars rover vehicles and Mars rover development. So I managed to do my second thesis at Coventry University, and by altering the design parameters of the Mars rover that I designed, I managed to link it to other potential assemblies in order to increase well, survivability of astronauts for space exploration. So allowing them to actually use basically just any sort of component to attach to other assemblies and increase their survival rate from there. And one of the examples I did use was detaching a Mars rover wheel to a customized wheelbarrow. So you might think, well, actually, yeah, that doing those sort of things increases their chance of surviving out there, and especially in those kinds of harsh conditions. But now I'm on my doctorate at the University of Warwick, and currently have done quite a lot of part-time jobs with teaching, and I'm currently teaching at the moment. And one of the jobs I actually did do, one of the part-time jobs, was with NASA at Newcastle in the Civic Centre. And I'm not gonna lie, I was a little bit nervous because there were going to be at least 3 retired astronauts there, and my job was to basically, be a doctoral student supervisor for a lot of these students that are in school and college, and supervising their projects, and they're all competing against each other, so that they can basically design an experiment that can be launched out into space and be conducted up on the ISS. And I had 2 of my teams that reached the final, but unfortunately they didn't get their experiment selected. But the experience was absolutely fantastic. And talking to, Michael Thole and Barbara Morgan, I actually thought that, being very much on a teaching role, teaching full-time and studying my doctorate part-time, I thought, oh, maybe I may not be able to be an astronaut. But when I was talking to a lot, especially to Barbara Morgan, she was saying, actually, teaching is actually a very good profession to be in order to become an astronaut. And she told me a lot about her experience. And she said, as long as she actually told me what to do, and I've very much written it down. And
Tell us, please.
and all the stuff I'm actually currently doing, well, most of it at least. Right now I'm studying how to perform ocean diving, and getting my tri-dive very much soon. Learning the Russian language as well, very much in advance, a year in advance now, so that next year I can get the qualification at the University of Warwick. So there's quite a lot of things I am currently doing at the moment in order to get into space, and looking at just a lot of jobs right now, especially through LinkedIn, and try and get either a full-time job within a space industry or perhaps a part-time job as well to support my to support my research. Yeah.
I'll come on a little bit to what the next steps are. But is there anybody else who wants to talk about their, thank you, Sunny, any space career or anything?
Or your aspirations?
Okay. Thank you. Right, great. Okay, so we'll move on. So where next? So so Sunny touched on that beautifully, actually, about he was now starting to look at careers. So where do you find a space job? Well, there's a really useful website called spacecareers.uk, which is currently working with 76 employers in the space sector, predominantly the UK. I was looking on there today just as get a feel for how much is going on at the moment. I'm certainly aware that there's an awful lot of space companies recruiting at the moment, ourselves included. And on the Space Careers website, there were over 90 roles in the space industry open just today. So it's clearly an area where there is a lot of recruitment going on at the moment. And so, as I said, it's a thriving industry and there's a lot of opportunities. And I know that there are some companies not covered by that, by Space Careers. So there's well over 100 roles open in the UK at this very moment in time, if you're looking for a space job. So if you want to find a space job, spacecareers.uk is a good place to start. Company websites, obviously most companies advertise their own roles. Follow LinkedIn, put space in your LinkedIn, and etc. is another good route. There are recruiters out there that will be looking for people with space experience, and specialist recruiters for the space market. So if you can get hold of those and get on their books, that's another good route to take. I know for the more student level, there are careers fairs, and I know for ourselves that we're supporting a careers fair in March at King's College. It's the National Students, I can't remember the whole name of it, but anyway, there is an event coming up in March in London. So if you want to find those opportunities, just follow your favorite companies, do your research, look up space companies, follow them on their social media, and you'll see when they're advertising for roles. Prior to that, prior to being ready to go out and actually hunt for the actual job, what do? You're a student. How can you help yourself get a role in the space industry? Getting work experience, actually having work experience or an internship is really highly beneficial. I cannot recommend it enough. So look out for those sorts of opportunities. There is a scheme run by the UKSA called Space Placements in Industry, and they get companies that put in an internship, 8-week internship program of work into the UKSA, which they then advertise, and then we recruit off basically to get interns. And being an intern is a great route in potentially to employment, both in terms of getting some really valuable experience that you can talk about it in for interviews, and also it can lead to jobs directly. So
I was just going to say, Catherine, I noticed a few names. I don't know whether you picked up. There's a few names on this call who I recognise from some of our internships.
So hopefully they will attest to the value of doing an internship. So so certainly do that. So certainly, and again, look at company websites. So there are other, not all internships are on this spin scheme, I hasten to add. So some companies will just do their own internship schemes. So look at company websites and follow them so that you will get the trigger of when they start advertising, and pick those up. And that will be through the websites, LinkedIn, Twitter. Just follow all those things for your favorite space companies and just follow them. Now, I've done graduate recruitment. I have sat with 600 CVs in front of me for 2 jobs. And you have to whittle it down to a number of interviews. And I've gone from 600 CVs to 6 at a CV stage. Okay. So that's really brutal. Okay. So how do you stand out in that environment? Degrees, fantastic. Doing the right degree, that's all great. But most of the CVs in that pile have probably got that. So you need to stand out a little bit. And how do you stand out? Well, I want to see people coming into the space industry that have a love and a desire for space. And so demonstrate that through your CV. Get involved with activities, UK SEDS, Royal Aeronautical Society, rocketry groups, astronomy clubs. Just do stuff that shows, and also follow your passion. Do something that's interesting and do some of these extracurricular activities. There are so many opportunities out there these days. Hackathons, design challenges. There was a recent opportunity advertised by the UKSA for a nanosatellite design. Get involved. Do these extracurricular things. Find opportunities to work as teams and work in groups of people. The space industry is a team effort. We all work in teams together. No, there is very, very few roles where you're just isolated and sat on your own and you're just doing your job. Most of the stuff, it's all about working together as a team. So developing those skills of working as a team, those soft skills, and then being able to talk about that at interview and talk about that in your CV to demonstrate to an employer that you can work as a group of people and in a team of people. Fantastic. So go and do those kinds of activities. So get involved, do all these things, and it will help your CV stand out for the poor people that are trying to sift through hundreds of CVs. There's more information. The UK Space Agency has quite a big section on careers, so there is lots of resources out there, and the ESA also have similarly lots of resources. So you just do a quick Google. There is no excuse for not being able to find that information on this topic. There is loads of information out there. There are lots of groups where you can find lots of other videos on people talking about their careers and how they got into their careers. For women in space, there's a whole WISE group so that feature interviews and talks and case profiles of people and how they got into the industry. There is lots to find out there, so there's no excuse in not being able to find out about it. Brilliant. So get involved, get stuck in, and we look forward to seeing people applying for jobs. So moving on to that, we can't do a talk like this without a quick plug. So Anita, you're going to...
Yeah, absolutely. And it's just so fascinating to hear some of the stories. And I just wanted to pick up on a couple of the highlights and themes around what people have said. And, you know, there have been so many different paths that we've heard about today, and it's clear, as I think it was Catherine, you said there are no dead ends. It's all about, you know, each role adds to your experience and your exposure and your understanding of who you are as a person, what you like doing, what gives you that motivation to get out of bed every day, and kind of helps you to take the right decisions as you go along. And Vicky's comment about maths, physics, chemistry being boys' subjects, I think every female on the call today has had that kind of drummed into them. And, you know, if you look at our team website, you'll see that in terms of gender balance at KISP, we're doing really well. And, you know, gender and background, as Jamie said, should not be a barrier to you being able to pursue your passion in the industry. There is literally space for everyone. So take a look at the backgrounds of the KISP team, and you can learn about what makes us tick, the things that make us excited, and things we want to do in our roles to help to move the industry forward. We've also got our website, kisp.co.uk/careers, and here are 4 open job opportunities that we have at the moment, and just check back regularly and see what we have on there. We are making sure that what we're doing in terms of recruitment is now getting onto the Space Careers website as well. So keep checking back, and as Catherine said, there are spinternship opportunities. We're hoping that we might secure some of those, and we'll just keep checking on spinternships, and we'll see whether any of those would be a route in for some people on this call, or for some of your colleagues and friends. So we've got a couple of minutes left. If we could just go to the next slide quickly, Catherine. Just wanted to talk about some of the ways that you can get involved, because as Catherine said, these are the sorts of things that give you experience, give you exposure, help you to understand what kind of role you could play in the industry. So you could simply sign up to receive updates on what we're doing. You could look to contribute on some of our projects, which span software, hardware, marketing activities. And you could participate in or mentor or judge some of our design-a-thon activities. They're kind of contained design competitions. If you're working on a mission and considering developing a mission, you could be an early adopter of our open source small sat design, or you could come along and give a talk about an area of interest. We're always looking for guest speakers to come and add some extra dimensions and perspectives that would help other people in the industry to find out more about what's going on. And of course, you could sponsor us. You can contribute to what we're doing and help us to accelerate the work that we're doing. And talking about what we're doing next in terms of our next meetup, the next one we're going to have is on the topic of all things CAN. And we'd be delighted to have a speaker to present at that next month's session on a topic of their choice. And Jamie mentioned Paul, he's our senior software engineer. He's going to be leading next month's session. Paul, welcome. It'd be great if you could share a little bit about what you're planning to talk about in next month's March meetup.
Yeah, hi everybody. So I'm Paul, and next month we've gone, into some really cool stuff about, careers today. Now I'm a proper, ones and zeros techie guy, so I'm going to be taking this to a very different place for next month and talking about some technical aspects of the design of a spacecraft, in particular about the CAN bus. So for those who don't know what CAN bus is, basically it's a bus technology that you find in your car. Many cars over the last 20 years have got it inside them, and increasingly it's been used in spacecraft design as well. We got quite a lot of experience of using CAN bus in space, and there's quite a lot to know. We've been doing some work over the last couple of months to evaluate how we can utilize it best. And so I just want to present some of the results of that research and thought processes, really. So it's going from careers to a very technical subject next time, but something that I'm very excited about, obviously, being a bit of a techie. So there we go.
Brilliant, thank you, Paul. And that's, as we were saying in the introduction, the whole purpose of what we're doing with the Open Source Satellite Programme is to cover that breadth and range of different disciplines and area of interest, the broad stuff, as well as going deep down into a particular area of interest that's going to help us to develop the open source satellite platform itself, and also share the knowledge that we're acquiring with other people. So if we can just flick quickly to the next slide, Catherine, we can close with the details of how to get in touch with us and how to get involved. And I'll close by thanking everyone for joining us today. I'm sure Catherine would like to join me in that as well.
Absolutely.
And thank you to Catherine for yet another brilliant presentation. And as we said, Paul's going to be presenting next month on the 17th on All Things Can, which is a really cool topic actually, and I hope that you'll be able to join us then. So thanks everybody, and goodbye.
Bye.
Bye.